Let's try another calculation. Suppose I want to calculate the probability of event D and H complement and W. Again, what this means is I don't know if any of the events have occurred. All I'm trying to find out is what's the chance of all these three events occurring. But again, the way the tree is arranged is in such a way that each stage now is conditional on the previous stage. So when that happens, the calculation is as simple as taking a product of all the branches. So again, the probability of event D occurring is 0.15. But once we get past event D, we get to this node right here, and we still have a chance of not completing the entire event. Either event H happens or event H does not occur. The chance of event H not occurring is 45%, which again we don't want it to occur. And finally, should we get past this, we still have to get through two options. Either event W happens or it doesn't happen, and it says there's a 35% chance of going through event W. Again, notice that the product idea makes sense here, in that we're taking the product of numbers less than 1. When you take a product of numbers less than 1, what occurs? Your number gets smaller. But that makes sense because what we're asking is we want one very particular event given other options that are possible. The more options you have, the less likely the event is to occur. So when we take the product, we'll get the final calculation for that probability. Let's try another calculation. Let's say I want to calculate the probability of event F. Now again, event F, for example, is not this 22% you see up here. Neither is it the 15% you see here. Neither is it the 5% you see here. All these probabilities are event F given that something else has happened. I just want the probability of event F, period. So really what's going to happen is, another way of viewing this is, what it's asking is, I'm going to start at this node. What's the chance that I wind up on one of the outputs that has F as an outcome? So one possibility would be I go through A and then I hit F. If that happens, I will have satisfied this event, the probability of F. It doesn't matter that other events are going to be occurring with it. There's no choice here because of the way F is located. So one possibility is event A happens and event F happens. What's the chance of that occurring? 0.22 times 0.22 is, if we start here at this node, event B happens and event F happens. That's another possibility. So one way to get to F is either I go through this path A and F, or this path B and F. So let me write that here. Or B and F. What's the chance of that happening? Well, again, these paths are disjoint, so I can simply just add the probability of B and F, which is 0.8 times 0.15. In other words, this 0.8 comes from probability of B, the 0.15 comes from probability of F, given B. Now that I can see there's one more path that leads to F, and that is through event G. So another way to get to F is or G and event F again occurs. So there's three ways of satisfying event F occurring. And I need to calculate each one because I want the total chance of F occurring. Now, again, there's no number here, G, but I can calculate what it is. After all, the sum of all these numbers here in this first stage have to add up to 1. There's only one node where we start, and there's 4 endings, and that's all that can happen. Nothing else can happen. So what do I have here? I have 22% plus 8 gives me 30%, plus 15 gives me 45%, so this must be 55%. The probability of G is 55% times the probability of F given G, which is labeled as 5%. And there it is. Calculating this product and sums will give me the probability of event F occurring.